Good afternoon, I'm Rupert Brown.
And I'm Ian Race. We're here today at Bletchley Park, where we've been looking at the lessons learned from Bletchley Park and the work that was done during the Second World War, and how applicable that may still be to people working in computing and IT areas today.
Yeah, and I think, as I say, one of the things that we shouldn't view Bletchley Park itself in isolation. Bletchley Park was set up at the beginning of the war, but actually a lot of groundwork had been done both in the private and the public sector to build very large, complex command and control organisations.
Yes, and Fighter Command gives you quite a good example of that, doesn't it?
Yeah, and that's probably the best known one, and we should remember that Fighter Command derived intelligence from Bletchley Park, which told them that actually the Germans didn't have quite as large an air force as the RAF had originally believed. However, Bletchley had its own very specific control network in the Y stations, which was a very rigorous way of collecting data.
So you've almost got the tip of the iceberg at Bletchley Park on top of a whole load of other people, Y stations, intercepts, and also supported by linguists and a range of other specialists.
Yeah, I mean, we shouldn't forget that all Bletchley Park effectively did in some ways was to translate the gobbledygook of the encoded data into German. That data then had to be assessed for its significance, and then of course they had to fill in the missing pieces of the jigsaw, because whilst they could decode the Luftwaffe code every day, they would have to look for messages going from the Luftwaffe to other groups like the Army or the Navy and say, aha, there must be something on the other side of that we need to then go and look for. So it was an intelligence-led data gathering operation, and it was also kind of a reverse engineering operation of an organisation that fortunately was quite transparent to them.
Yes, and what we have, of course, which is illustrated here, we have the technology signified by the German Enigma and the response, the bomb and the Colossus machines to the mechanised technology. But also we have the people organisation, and there's, surprisingly enough, organisational risk aspects. A lot of the clues that enabled the code breakers here to help break the codes were actually as a result of poor operational practice, and that then gave them clues in or removed possibilities of the mechanised number of possibilities that made it easier for these codes to be cracked. But the best thing, of course, was to try and also capture the code sheets, which at times helped.
Yeah, and it would give them a window of opportunity, and again give them that intelligence, not to just reverse engineer the code, but reverse engineer the system. It was very interesting, in fact, when we went over to see Colossus, that alongside the Colossus machine was actually the mimic of the Lorentz encoding machine, because they actually had to type in, all Colossus gave them was the wheel settings. It didn't decode the message. So they then had to type in the encodings based on the wheel settings to get the German out. So it was a multi-stage process, and I think it's very important that people think about the problems in terms of the stages and the boundaries between the different people that were reverse engineering and managing that process.
Yes, so code breaking was very much a team effort. Very much like today when people are building large complex systems, it's a team effort. It's not one person, although some people will contribute the sparks and key technical ideas.
But it's also, as I say, it's around the boundaries of people's roles and responsibilities. And those things weren't done overnight. Okay, the work done before the Second World War let people know where they fitted into a team, but establishing the boundaries during the war was quite a unique operation, because you had a mixture of academics, civil servants and military personnel here. So that also made it a more complex challenge.
Yeah, altogether a fantastic achievement.
Yeah, fascinating piece of technology. It's the translation from the electronics we know today from the electromechanical world of before the Second World War. A fascinating bridge.